We are now in Module 13, where we're going to be looking at attacking web servers. We're going to talk about what web servers are all about, what are some of the attacks against web servers, and some countermeasures. So let's have a look at what we're going to go through. If you look over here, we have several different areas. We're going to start off with some concepts. We're going to look at an overview of what web servers do and a little bit of their architecture. From there, we're going to move into different web server attacks. And then we're going to look at the methodology to step through attacking a web server. And lastly, we're going to overview some of the countermeasures for web servers. Let's get started with the first one and look at some basic concepts of web servers. We're in the first learning objective, and what we're going to do here is we're going to look at some of the basic concepts of web servers. So let's have a look here. What I want to emphasize here is that a web server is essentially a file folder whose contents are available over the internet. And those contents happen to be in HTML and other web-based processes and web-based protocols. And it's gone far beyond that. But there are many different reasons for web servers being compromised. It's very interesting how many web servers that you can find live online that are highly compromisable due to some of the things that we see here, right? Improper file and directory permissions. That's going to be whether it's ext4 or NTFS, or whatever your underlying file system is, it needs to be properly secured. Unnecessary default backup or sample files. And when I first started working with web servers, I actually really appreciated the sample files that came with the web server. And it helped give me kind of a guide as to how I could create my first websites. Misconfiguration of the web server operating system and networks. So if your web server is running on Linux and it's kind of like out of the box, not secured, or Windows, then that could be an issue. Bugs in the software. So you may have a web server that is just fine, functioning great, but the software that was written is buggy. Administrative or debugging functions that are enabled or accessible on a web server. So in other words, what I can do, and you can find this with Google Dorks, you can go online and find web administrative panels, and some of them are very hackable also. And then the use of self-signed certificates. So when you use OpenSSL, or actually more like Microsoft Certificate Server, and you create your own PKI, you can create your own self-signed certificates, and these are not going to be very easy to use out on the internet. And not using dedicated web servers for your services. So you have a server that is running a client-server HR system, and that client-server HR system is on a domain controller that's also a DNS server, that's also a DHCP server. Hey, why not put our web server on that too? So no, you want to make sure and isolate the components and the elements of the web server. Otherwise, we're going to have a very easily compromised web server. Let's go over here, and I believe that you would understand some of the problems with a web server that gets attacked. I mean, yeah, user accounts and secondary attacks and stealing of data and many, many other types of impacts can happen when someone hacks a web server. All right, so let's look at some of the web servers. We're going to look at three major web servers, and I'm glad we're going to start with Apache first, because it is the most Apache and Nginx kind of vie for the top web server. And when we look at these web servers, Nginx, Apache, and IIS, I want you to keep in mind that these web servers aren't all just running on a server. They're virtualized and containerized, and they're highly flexible web servers. So let's have a closer look at the architecture of an Apache web server. And we'll do that with some of the other web servers too. So let's have a look. So with the Apache web server, one of the good things about it's open source. By the way, you can run Apache, it's usually run on Linux, but you can run it on Windows and other operating systems. And you can use that to host your websites, obviously. And it is very high performance. It's scalable. It has great features. And in general, we have several different areas. Right here is the server itself. And on the back end, we can put together an application server to forward and receive requests, put out dynamic content, and so on. And over here is a client. That's you or me on our laptops. And we are requesting some type of information. And another thing you want to keep in mind is this client is going to be downloading all these resources. We'll talk more about that in the next module. But here we have the actual Apache web server. Let's just have a look at each one of these modules. The first one is mod_SSL. And what do you think that purpose might be, right? It's a module for SSL. So yes. So what does it do? It helps with TLS, SSL. It helps to enable your web pages to run using HTTPS. So it's actually very good. So in terms of the functionality, it's going to be there to help you encrypt the data of your web server. Let's look at the next one. This one is mod_auth. What do you think that one does? I mean, auth, AUTH, right? So it's going to do authentication for your Apache web server, and it's responsible for identity verification of the server, checking credentials, usernames, passwords. Let's go to the next module, mod_rewrite. Unless you are somebody who works with web servers, it might not be obvious what that would be. What that is it's a URL manipulation tool that allows to rewrite URLs on the fly, so you can modify an incoming URL request depending on what rules you put into this module. And it's useful for redirecting URLs, creating user-friendly URLs, and also you can create extra security measures on that module too. Well, let's look at the next one, mod proxy. What do you think this is? Oh, hey, I just guessed. It's a proxy. In this case, it's a gateway for the Apache server. So the Apache can forward client requests to another server, like for instance, an application server that you see right over here, this application server. You can forward requests there and it gets responses returned and then send those back out to the client. It's useful for load balancing. It's useful for caching requests. All right, let's look at the bottom one here. This is the BMMTM module, and this is actually not a standard module like the others. It's a third-party agent for the Apache web server. As you see there, it says agent, and it's designed for monitoring, messaging, and extending the functionality of the server. So yeah, we have a lot of different modules in the Apache web server. And this is a basic architectural overview. There's a lot of extensibility in Apache web servers. But there's also more to an Apache web server that we need to discuss. If we look over here, we see that an Apache web server has vulnerabilities. Let's do a quick overview of some of the vulnerabilities that we find in the Apache web server. One of them that we'll see is response splitting, where you have an improperly validated input that allows an attacker to inject malicious headers. So this is really a header attack into a response. And you can do all kinds of stuff with response splitting, but we'll look at that in just a little while. And then we have HTTP2 DOS and mod macro buffer. And we're going to look at several of these in just a little while. So I'm not going to spend too much time talking about each of them. But another one that we'll see is insecure default configuration. So I have Apache, and I've done this before with Google Docs. Go out and find the default Apache pages on the internet. Somebody just stood up a server, and it's out there running with a default page. Then we see DNS and path traversal. And then we're going to spend an entire module on SQLi, SQL injection. So yeah, there are vulnerabilities. Like I said, we're going to focus on this in just a little while, get a little bit deeper into each one of these. But while we're here, let's have a look at IIS. IIS is Microsoft's web server, and it's been around for a while, and it's been pretty competitive. I remember when Microsoft first came out with IIS, a lot of people were skeptical. What's IIS? Is it going to work? Is it going to crash all the time? And it was pretty clunky in its first versions, but now IIS is a highly competitive, highly flexible, highly extensible, and secure web server. So let's have a look at some of the components of the web server. So IIS, it's a nice little service, runs on Microsoft servers. You can run it in many different places, and it's flexible, easy to manage. It has a nice, I like the UI, the user interface for IIS, but I also like the tools that you can have at the PowerShell level to automate functionality. But let's have a look at it here. So first of all, we have kernel mode, and on the left here, and on the right, we have user mode. And so this is where we have a HTTP protocol stack, HTTP sys, that operates in kernel mode. It handles incoming requests. You see the client here. I should have worn a red tie. I could have been like the client there. Going through the internet, going to HTTP sys, and requesting this directly from the network and passing it to the process that is needed in user mode. So in user mode, this is where most of the IIS processing happens with services and module. And as you're well aware, we want to be very careful with kernel mode and those kernel mode processes to protect them. But either way, let's go to user mode and look at, actually, let's start over in kernel mode and look at a little deeper overview of http.sys. So it's a kernel mode driver. It's listening for requests, listening for those HTTP requests, and then when it gets a request from a client, it's responsible for routing that request to the appropriate worker processes. So that's what it's going to be doing. And this really depends on how you've configured the server. So in terms of performance, http.sys is, again, kernel mode. That makes it efficient. It makes it so that we reduce the overhead, and especially when we're dealing with context switching between the user mode and kernel mode. All right, now let's go over to user mode. And in user mode, we have multiple components. The first one I want to look at is WAS, which is Windows Activation Service. What it does is, for your application pools that are in the web server, it helps manage their life cycle, and it'll stop and start worker processes. So that's what it really is doing as needed, depending on what you've done for it programmatically. So if we look at WAS, it works very closely with http.sys to make sure that the requests are handled and moved to the appropriate worker processes. And also, it's going to manage host configurations, so application host configurations. The next thing we look at then is the www service. So this is one of Microsoft's older services. It's obviously been updated over the years. It's part of IIS, obviously, and it's part of the management for the core IIS server functionality. It'll stop and start worker processes, also maintain configurations. And now we move over to, let's see, so we have WAS over here. Let's go ahead and have a look at 3WP. So this is actually a worker process. And what it's going to do is that WP-W3, as we see here, worker process, is where the actual web applications run. So down here is where we're going to be working with applications. So what it'll do is it'll process incoming requests through svchost. I like calling it svchost, but it's actually SVC host, which is service host. That's the back-end process on Windows systems that manage all your services. And so we have several different things going on here. We have the web server core over here on the left. We have native modules here in the middle. And then we have the app domain on the right. So the web server core handles the core web server functionality. Like, for instance, AAA, authentication, authorization, and it doesn't quite do accounting, but it does request processing. It does caching, stuff like that. Let's have a look at the middle one, the native modules. These are built-in modules that Microsoft gives us for IIS that do authentication, static file handling. They do logging. So there's that AAA, right? And where we're going to do accounting, right? So that's the logging right there. And also the native modules help with caching. And then on the far right, we have under app domain, we have managed modules. These are .NET based modules that give us some more functionality, like other forms of authentication, I guess you could say. Usually what this is going to be doing is they're going to be customized and developed by developers. So they're going to customize that. So let's kind of drill down into some of these. Let's look at the application pool. And if you look at the application pool, what it's going to do is isolate different applications from each other, making sure that if an application fails, it doesn't affect the others. It helps with security and reliability. We have another one too that's very important, which is down in this one. We have the application host.config, and it's the main config file. We just have quite a lot of functionality here. So with IIS, it's flexible, it's functional. We have that http.sys that handles all those incoming requests, handing things over to the worker processes. And so IIS is a very good web server. I would like to take more time to talk about how to use it and so on. We can talk more about that when we get to the lab. But either way, IIS has some vulnerabilities that we need to talk about. So just like every web server in the entire world, there are vulnerabilities. And this is a table that you should spend some time looking through. We're going to drill down into some of these in the near future here. But one of these is a trust boundary violation. And I was talking before, trying to remember which module it is, but I drew a picture and I talked about how trusts work. Trusted and the arrowhead and all that kind of stuff. Those are domain trusts. This type of trust is a very important concept for security in general. And when explaining what a trust boundary is, I remember trying to explain it to students over and over again, and these are very technical explanations. But I finally found a way to explain what a trust boundary is. It is where your login stops. It's where your login stops. So let's say that I'm at work and I'm logged in to my local domain, and my login doesn't stop in the local domain. In fact, I can use the login and I can get into shared folders. I can open up that project in Microsoft project I was working on. I can go to my app server and go to HR and let them know that I'm taking the next month off. I do that every month and stuff like that. But I open up a browser and let's say I want to log into Hugging Face, that repository for all of those large language models. And guess what? I need to log in again. I've just crossed a trust boundary. My login no longer applies. And to a certain extent, trust boundaries can be amorphous, not quite understood, because we have the idea of identity federation. And with identity federation, I can take authentication information from within one trust boundary and have it used for authorization in another trust boundary. So it gets amorphous. It gets murky where that trust boundary actually is. And so if somebody violates a trust boundary, in other words, I shouldn't have been able to use my authorization to get there, then I'm going to be in trouble, right? Unauthenticated entities that are able to access those things. We have authentication bypass. We'll talk a little bit about CRLF in a little while. That's carriage return line feed. And then we have a secure and arbitrary paths and We have IIS server elevation privilege vulnerability. So many different things. We'll talk about a few of these when we go a little bit deeper into the module. But I would ask that you spend some time when you get a chance and just look through some of these. And again, we're going to talk about a lot of them. So I'll leave this for you to have a look at. Okay, the next web server we're going to talk about is Nginx. Nginx is another extremely useful web server. If you were to do an internet search and look at the top web servers currently in use, Nginx is 1 or 2 in the top list, like I was talking about with Apache. I can't remember if it was Apache or Nginx that was number 1 or 2, but I believe Nginx is number 1. And so it behooves us to take a look at the architecture of Nginx and how it works. So let's have a look. Okay, so Nginx, this is actually a very good point right here. It's high performance. That's why Nginx was put together. Super scalable. It's wonderful, and it does reverse proxying. It does load balancing, and it's just an extremely good server. And so let's have a look at what it does here. We're going to start with the master process here, then move into the worker processes, and then we're going to have a look a little bit at its scalability, proxy caching functions, and back-end servers. So let's get started here. Okay, so what we see first of all is the master process. So the purpose of this master process in Nginx is going to manage the overall operations of the server. So everything from creation to configuration, termination of worker processes is what we find in the master process. In terms of its functionality, it's going to take configuration files, it's going to read them, it's going to start worker processes and handles. It's going to help with changes to the configuration file. Yeah, that's what this does. So this master process is intricately involved with the worker process. So if you look at the worker processes, we have clients that are interacting with the worker processes. These are really the backbone of Nginx's ability to handle requests. So each, you see we have 3 of them here. Obviously, there are going to be a lot more than that. They handle incoming client requests. The Nginx really has a really good design to have a non-blocking, event-driven architecture. So each of these worker processes will manage thousands of simultaneous connections to the Nginx resources. So it's actually pretty cool. All right, so if we look at the scalability of Nginx, these worker processes being able to handle thousands of connections at once without any blockage occurred. This is really what makes Nginx so scalable. It's pretty cool stuff. All right, let's go down here and look at, well, we'll go to the right first and look at the proxy cache. So it's going to store copies of content that's frequently accessed. So we're trying to reduce load to backend servers. Also, we're trying to speed up response time. So that's often why we cache stuff anyway. So client is going to request content, Nginx is going to go back and say, hey, do I have that in my cache? And if so, it pulls it from cache instead of going and digging up that content. All right, let's look at the cache loader over here on the upper right-hand side in the cache manager. And so the cache loader is going to load those cache files into memory when Nginx starts, making sure that we have that cache available. And the cache manager is going to make sure it understands and manages and checks that size of the cache content, making sure that it doesn't like suck up all of the available resources of Nginx. And also it helps with timing out some of that content. So if the content is outdated, it'll FIFO it out of the cached server. Really, it's a timeout, not a FIFO. First in, first out is what FIFO is. All right, so let's look at the back end. Over here we have web server, application server, Memcache. So the purpose of the back-end servers, they give you actually the content that you're going to be looking for as a client. And it could be web servers, application servers, stuff like that, Memcache servers. So first of all, the web server, we have HTTP. which is standard, right? Content, we fetch that. We have a fast CGI, it's dynamic content that we use to interact with application servers. Memcached, so Nginx can interact with these Memcache servers. Again, this is to make things faster, restore stuff faster, retrieve it faster from the database. And then lastly over here, hey, that's you, that's me. One of these clients, though, should have a hoodie because we're going to be hacking the web server later. So what we're doing is we're loading up clients, we're interacting with APIs, resources, and we're moving that data through the Nginx server to serve up web app content. But like all the other servers, Nginx is hackable. And so if it's misconfigured or any of these issues happen, we're going to be in trouble. Let's have a look at an overview of some of these. Some of these will be repeated because a lot of them are endemic to web services. Null pointer dereferencing, SSRF, this is server-side request forgery. We're going to be doing some of these attacks, by the way, in the labs. They're actually very fun. RCEs, that's a remote code execution that could happen because of exposed configuration settings. Again, back to certificates. If it's not validated appropriately, then we see SQLi coming in, and we're going to be going in depth on SQL injection. And then we have unauthenticated private key access. And when we look at this, let's put this under the category of secrets. Especially when we get into the cloud, we'll see that revealing secrets, certificates, private keys, things like that is a big, juicy target for attackers. And then excessive memory usage and CPU exhaustion. This is, again, one we're going to talk about in the future here, HTTP2. And then OS command injection and default permissions. So you get certain versions of Nginx out of the box. And maybe you also have default permissions on your OS. Put those together, and you can have vulnerabilities. So Nginx, just like IIS, just like Apache, just like any other web server, has their vulnerabilities, and they can be hacked. So if these web servers can be hacked, I guess the question is, how do we do that? And that brings us to objective number 2. We're going to demonstrate some of the different web server attacks that we're going to have some fun with in the lab also. So let's have a look at learning objective 2. Okay, so the first one, we've seen this before, but let's go ahead and revisit it a little bit. What the attacker does is compromises a DNS server and redirects somebody to a fake website. We've seen this over and over again, so I won't belabor the point on this one. The next one is one that I'll slow down on and talk a little bit, because not only do you need to know this for the exam, but you need to know it in general. And that's called a directory traversal attack. So what do we mean directories? Well, a directory is like a folder in an operating system. And what did I say about what a basic web server is? It's a folder with HTML file in it and other content in it. But where is it located? If you look down here, you'll see that we have on a Windows machine the root, and then underneath that root we have inetpub. That's one level lower, and then down there we have www root, and then perhaps we are in this good shopping folder. So if I want to get to the root, I do // takes me up one level. // takes me up another level. // takes me up another level. Now, if I have not characterized the web server architecture and I don't know all the folders, there are some really cool tools we'll talk about that you can use to find the directory architecture of the server. But if I don't know that, then I might actually see this bullet point, use a trial and error methodology to find that. But if you look over here, what I can do is once I know that location, I run my .. and over here what we're doing is we're trying to essentially get a command line from a URL. We'll see that a little bit later also. It's actually pretty interesting. So what we're doing with directory traversal, we'll see this over and over again, especially in the next module, a little bit in SQLi. We're trying to find our way to resources on the web server by traversing that directory structure. So the next attack that we're going to look at is web server misconfiguration. And that is something that is very easy. If you were to, let's say that there was a small company, and in the accounting department, there are 3 people. And one of the people who likes to help a lot and really excited about technology, but he's an accountant. His name is Fred. Someone says, hey, Fred, we need a little website locally. Can you just make it happen? And he says, I've never done that before. And they say, hey, go to YouTube and let's make it happen by Friday. And he does it. Do you think that web server will be configured properly? I think not. And I use that as an example because I've seen examples where department level web servers were set up and they were easily hacked. So in this case, one of the things we see is, for instance, a server status page that is default and it shows up, or unsafe variable usage. So somebody can dump those variables here in Nginx. This one here is HTTP-conf in Apache. Or maybe you can do that // directory traversal. You can get to directories because of the web.conf config file on IIS that's improperly set up. So web server misconfiguration is another type of attack. The next thing we want to talk about is HTTP response splitting. In HTTP response splitting, I want to focus on this a little bit because we're going to see this occur in a couple of other areas too. So this is actually a fun attack to do in a lab or in your test network, or if you find one of these pages that are vulnerable to it. So let's have a look at response splitting. So with the response splitting, an attacker is going to inject malicious data into an input field. We'll talk about where those fields are in the next module of a web app. And so what's going to happen is that data is going to be included in the server's response headers. And this causes the server to generate 2 separate HTTP responses instead of 1. So what we see first of all is we need to find that input field. And that might be, for instance, author or location. That's a very common one you use. Then what we do is inject those malicious characters. Like we'll talk about, I said we're going to talk about CRLF, but CRLF basically stops the processing so that you can insert your own code into there. Or /r/n is how you would do it, which is the end of the header. So we can do that. And then the second thing we're going to do is we're going to create a crafted response. So we put together a crafted response. So the server, since it doesn't validate the input, will process whatever injected data that we throw into there. The CRLF sequence will cause it to treat our data as the hacker as a start of a new HTTP response. So the result is it splits it in 2 HTTP responses. And the first response is the one that the attacker can control and allows the attacker to include other headers and so on. The second response is the valid response down here. So let's have a look at what's actually happening. If you look over here on the left-hand side, you see a server code. And over here, you see a string author. And then you see that request get param. So what we're doing in this case is we have a normal JSON input. We have an HTTP response, which is going to be that HTTP 11, that 200 OK, right? We're setting a cookie that's equal to JSON. The malicious input is actually the one that says the hacker. So we see that coming out over here, and that is Jason the hacker. And you see that Jason the hacker is using that construct that we were looking at a little bit before, which is the /r/n HTTP 11, and we see that OK coming back. So the first response, we control that with the author, Jason the hacker. The second response is from the server. So the attacker's input is going to manipulate that server into sending two different responses, allowing us to do many different things. So what can we do with a split response? And this is why I said that we're going to see it over and over again. We can do session hijacking with a split response. We could do web cache poisoning with a split response. We could do phishing. We could do many other things. And so really one of the major defenses against this, we'll talk about this later though, is proper input validation. Okay, so now we're going to look at another attack, and this is a cache poisoning attack. We've seen many technical or protocols, etc., that do caching. We have ARP cache, DNS cache, and we also have web cache. So what web caching is when I go to a web page, we actually know we never go to a web page. You know what we do? We bring the web page to us. So when I do www.certifiedhacker.com and I hit enter, I send a request out to the web server to that folder I was talking about, and I download all those elements locally. And guess what happens to those elements? They are cached. So the short version of this story is that the attacker swaps out the cache with his own. And so when I go back to that web content, instead of taking me to the cache content for the actual site, it then takes me to some type of hacked content that the attacker might have. All right, the next one we look at then is SSH brute force. We've already talked a little bit about hacking SSH, and we'll do more of it as we get a little bit deeper. But what we're trying to do is have a nice encrypted tunnel, and so the attacker is going to do a brute force against SSH, and if they can be successful, and like I said, there are many different ways to do this, then they'll be able to do other exploits, send malware around, etc. One of the ways to do that brute force, it makes it a lot easier actually, is using AI. So let's look at the prompt that we're using with SGPT here out of the shell, and that is attempt FTP login on target 1.11 with Hydra using usernames and password from word lists. And so in this case, we're going to have to provide it with the word list, and it goes and begins attacking the web server. So AIs make it a lot easier. The next thing we look at is HTTP2 continuation flood attack, and this exploits the handling capabilities of HTTP2 continuation frames. And so what they do is they send a huge number of these continuation frames on a single TCP connection, and then they overwhelm the Apache server. And as you can see over here on the right, we have resource exhaustion that occurs. So it's like a DOS attack against the Apache server. The next one we look at is called a front jacking attack. So if we look at this, this really is focused on the front end, not the back end. So the front end components of the web app, and this is all often done against Nginx, and it's because of poorly configured Nginx, and specifically the reverse proxy. And so you'll see this when we get to the cloud, shared hosting environments, right? And so it'll combine several different elements, the carriage return line feed, CRLF injection, or HTTP request header injection, or maybe cross-site scripting. And so they are going to inject a new host header, and because of that, they're going to be able to redirect a user to malicious content. And then there are other web server attacks, many different types here. Password cracking, DDoS, MITMs, phishing attacks, web application attacks, which we'll see in the next module. Okay, so we are now in Learning Objective 3. We're going to look at what we're going to do to actually run web server hacks. So we're going to look at that methodology here in Learning Objective number 3. So let's have a look at the first overview of what we're going to be doing. We're going to start with information gathering, and this is what we do as part of our hacking methodology anyway. Then we move to web server footprinting, and in Module 2, we talked about footprinting. We're going to do this for web servers specifically. Next, we go to website mirroring. This is not absolutely necessary, but it really, really does help to just download the entire website. Then we look for vulnerabilities in the HTML, the architecture, etc. And then we have some choices depending on what we find. One of those choices is session hijacking. And then the last choice here is password hijacking. Let's have a look. Okay, so first of all, robots. They're everywhere. No, we're not talking about those kind of robots. We're talking about the robots.txt. What's the purpose of the robots.txt? So it has a list of server directories and files. What kind of list? It's a list that says, hey, web crawler from Google or web crawler from Microsoft, don't look here. Don't crawl these directories. Don't look at these files. That sounds very, very interesting if you are an attacker. So one of the files that you might want to find is robots.txt. If you look at here, it says, look at this, disallow. So it tells you all the stuff that the web crawler shouldn't be looking at. So maybe if you're the attacker, that's something you might want to look at. So that is a good file to find on a web server. The next one is just doing some banner grabbing on the web server. And we're going to use a couple of different tools. Very interesting here, we're using Netcat at the top here. And instead of setting up a Netcat listener, we're just using it to target that port and pull out information about that web server. So in this case, we see that it's IIS 10.0. Down here, we're using Telnet. Again, I was talking about tickling ports with Telnet. And we do www.moviescope.com. And then we give it port 80. And again, we get identification of that web server. So we're just grabbing banners here, trying to find out what type of web server it is. And we could do similar work with AI. In this case, again, with SGPT, that makes use of that backend API to the LLM. And so what we're doing is we're performing web server footprinting on 1.22. So there we go. In this case, we're giving it a choice as to how to footprint the web server. Over here, we're not. We're saying do footprinting on 1.22 with Netcat, and then we get an output from Netcat that tells us what type of server is being run on that resource. So next we talked about this in module number 2, and we're going to see this come up again when we get into IoT. So hey, I hope you already have an account, or at least you have used a Shodan before. And what we can do with Shodan is we can search for that web server and have Shodan show us some of the information about the web server and let Shodan help us with the information gathering. Okay, so now let's have a little bit of a focus on some components of Apache that we might be able to use in order to enumerate user accounts. This is called abusing Apache mod_userdir. And what's the purpose? We're trying to enumerate user accounts. What user accounts? User accounts on the Apache server. So what is this component? What is mod_userdir? Well, it's an Apache module. What we do with it is we have user-specific directories that can be accessed through URLs. And so you could have, for instance, www.certifiedhacker.com/ and then you'd have a tilde, and then you'd have the username. So that's what it's going to do, is going to allow those directories to be accessed for those users. So let's have a look at the exploit. And by the way, it's going to allow users to publish web content under their own home directory. So that's how it's normally used. So with that, we can find users. So what's going to happen is attackers can use this mod_userdir module to enumerate all the usernames that are on this web server. So we're going to list them out. We're going to get specific user directories. One of the tools you see right here is Nmap. This tool can be used to do that. And so with Nmap, if we look down here, we're doing Nmap-P80. And so we're doing port 80 for Nmap. And then we're using a specific script to do that, which is HTTP-userdir-enum. and then we give it the target. So this would be the target web server. And so what it does is it uses Nmap to scan at port 80 and target that server using that script, and checks for the presence of user directories. And over here, we can also do a customized scan. Let's have a look at this Nmap command. Again, port 80, and in this case, we're using user, dir, and enum, and then we give it some arguments to dump into that command. We have word lists, so that way we can do like the original command, but we use a custom word list of more common or likely usernames that we would find on that web server. And so it helps us to increase the possibility that we'll hit an actual username. All right, let's go to the last one, bypass detection with custom user agent. So what are we doing here? We have, again, another Nmap command, and we're going to run a script. In this case, the script is HTTP brute, and we're going to put some arguments into that script. And what we're doing is we're using a different user agent. So what is a user agent? A user agent is the process or the program, I guess you could say the app, through which we are accessing the web app or web server content. So normally that user agent is going to be a browser like Chrome or something like that. But if I am attacking that website, the user agent can be something like Burp Suite. So that is what I'm using to access the content. So let's have a look at this again and see what we're going to do with this. The command is going to change the user agent string that we see here in the request that was sent by Nmap. We're changing that string. Why? Well, we want to avoid detection systems. Why? Because the user agent is Nmap. So we don't want them to see that. So we're going to change that user agent string and evade detection by substituting that out. So as you can see, we have multiple ways to go to that mod_userdir in Apache using Nmap to pull user information out of that web server. What else do we have? We have directory brute forcing. This is actually very important. Finding directories on the web server really helps you understand where all the really cool content might be. Also, if you upload content into the web server, you want to find out what directory it ended up in. And so that's where we have tools like dirhunt. Another tool would be dirbuster. Another tool would be dirb. There are many of them out there to help you find that. And so in this case, we do a dirhunt against the site, and we get the directories. We can also put the output somewhere else so that we can map it out and understand how that web server is put together for that web app, so we can understand where the content goes. We can do a lot of this with AI. Again, backend ChatGPT, whatever model that you're using. And so we do shell perform a directory traversal on the target URL of HTTPS server.hacker.com, and you hit enter, and it goes through and finds all the directories. So makes it much easier, more convenient. One other thing that I really haven't said about all of these SGPT commands that we're using, and this applies to script commands. This applies to complicated bash commands, and this applies to complicated PowerShell commands. And you want to make it as convenient as possible. So what you do is you create categories for these commands, and then you use a note application like Obsidian or OneNote or something like that to collect all of these commands so that you don't have to remember how to use it. Especially if you have an extremely useful prompt, you can go back through, copy it, change the target to another web server, and just use it again. So you want to make sure and copy these, keep records of these commands. And hey, lastly, about what I'm saying here is if you're doing that, it makes it easier to study for the exam under those categories too. Right on. So let's look at the next one. The next thing we want to do is just good old vulnerability scanning. And so we're gonna run a scan, one of the best tools out there. In fact, if you go to Acunetics.com, they have very nice tools. We're going to refer to them many times, but Acunetics, if you look at the far left side over here, we have other tools like OpenText and Tenable.io and Immunoweb and Ivancy and many others. So you could just run a standard commercial tool to do a vulnerability scan against the web server. There is a very nice tool out there that is very effective against certain implementations of Nginx. It's called Nginx Pwner. You want to pwn and own that Nginx server? Well, we can do this one. So what it's going to do is it's going to identify common vulnerabilities on Nginx. So the first thing you want to do is have a look at the path list. And so Nano, that's just an editor on Linux. And then we're going to run Nginx Pwner once we have the URL information. And this is what it's going to look like on your screen. And it's going to go through and find the vulnerability. So this is really a vulnerability scanner, but it's targeted specifically at Nginx. But what if you wanted just to get a quick overview of some of the potential vulnerabilities on Nginx? What if you found out the specific version of Nginx and you just wanted to look it up? Just go over to the Google Hacking Database. You can click on the little spider, go to exploits, and then you look up the version of Nginx, or you look up the version of Apache, or you look up the version of the web component that you found, and there might be already a wonderfully put together attack that you can use right out of the box. Makes it much easier. However, if you're not sure how to use that attack that you found, you can always just ask an AI. And this is what we're doing here. So in this case, what we want to do is find exploitable vulnerabilities. And what we're going to do is identify OS, that's good, that's one, and services, so that's two, running on the target, give it an IP address, and install and launch Searchsploit to find out possible exploits associated with the OS. Searchsploit, this is one of my favorite tools. I like Searchsploit because if you are in a terminal window like in Parrot OS, you can type in Searchsploit and then give it the component that you're trying to find vulnerabilities on, and it'll find it right there on the terminal. So in this case, we're using that. And then what it's going to do is it's going to run Searchsploit and find potential vulnerabilities. So Searchsploit is pretty cool. Over here, we see the output of Searchsploit. And so you see we have SMTP server information. We have paths to each component. And then down here, we have DCOM components, etc. So it'll actually go and find stuff. It's a pretty good little tool, Searchsploit is. And then we can do stuff like password hacking. And so there are a lot of tools out there for password hacking. One of them is John the Ripper. Another one is Hashcat. Another one is THC Hydra. We have a lot of them out there. So for this one, what we're going to do is use Hydra. That -L is going to give it the path to usernames. And that -P is going to give it the path to passwords. And then you hit enter and then go get a cup of coffee. If it's actually a real password list, it's going to take a long time. But in the case of our labs, they're curated, so it shouldn't take very long to find the answers. And this one is just a help listing of Hashcat. So great tools for grabbing passwords. And we have another tool that is very good for looking at misconfigured Nginx. So this is path traversal via misconfigured Nginx alias. We're using Yabi for this purpose. And so if you look at the Nginx config file, this is the one that's messed up. And so it has a lack of a trailing slash, so the attacker can manipulate the URL in the file outside the designated web root. They're showing you a little bit of the command. So what we do is we do a Kuyabi, and then we do the path. And then as you can see here, the ..///, right, we're doing directory traversal, and we're able to characterize the directory structure on that Nginx server. So what we see is that there are a lot of tools that are available to attack a web server. We see here we're characterizing the folder structure. We saw that with DirHunt. I talked about Derby and so on. We might be able to find content and find secrets on the web server and many other things. We're going to look at this again more deeply when we get into the lab. All right, so you don't want people hacking your web servers? Well, either do I. And so that's why we have countermeasures. And that's what brings us to objective number 4. So let's look at some countermeasures for web server attacks. Okay, so the first countermeasure, update the web server. Okay, will you please update your web server? So what this is talking about making sure that we do what I often call ubiquitous hardening. So ubiquitous hardening means we're going to update not just the operating system, update not just the web server like IIS or Apache, update not just the components that are in the web app, but update every part of that, including the firmware on the hardware of that web server. You need to cover all of the angles. And one of these also talks about that we're going to patch all of our domain controllers. We're going to have a backup. We're going to have a backup plan. This is so important. Oh, I remember I was working for a startup, and we had web servers serving content all over the world. And that was my first ever job as an IT director. And the owners of the company and the president of the company came into my office. And that was the biggest office I'd ever had up to that point. It was huge. I had like a couch and all other things in the office. It was wonderful. Either way, they came in and they said, we need to give you a project. I was extremely busy, but they gave me a new project. And the project was they wanted all the web services to look differently. Essentially, we're going to take the skin, the way, the presentation of every single component in all of our web app services and make it look new, refreshed. So I took on the project. I made a project plan. I hired graphics people. I got it all together. They gave me a deadline. We worked hard for about 3 or 4 months. Overtime. I let other projects lapse. And then we went into the dev team. We had a dev team and a web team. They were kind of together on this. And back then, the head of the dev team was called a webmaster back then. And his name was Matt. He was amazing. He's since passed away, but he was a really brilliant guy. And we go into the team. The managers are there. Other directors are there. The owners are there. And we hit the button. And over many minutes all around the world, the content is updating. We're like, yeah, it looks great in Singapore. Yeah, it looks great in Japan. Yeah, it looks great. And we're naming all the cities. And finally, it's done. It's wonderful. And there was cake in the conference room. It was wonderful. And I go back to my office. And the first thing I do is I grab an eraser. I had a giant whiteboard. I erased the entire project we've been working on, and I started resetting my office for new projects, new project plans, and to finish the old ones. And as I'm doing that, more management starts filtering into my office. Like, we need to talk to you right now. We need to talk. You know what? They had not discussed any of our updates that we've been doing for 4 months with any of the other team around the world. And so when our website rolled out, everybody freaked out around the world. And they said, what are you doing to our website? You didn't tell us about this. So they told me to take it back down. After all that work, I had to take it back down. So I go back to our web team and our dev team, and I say, we need to run our back out plan. See what I mean? That's what I'm talking about. So what we did is we ran the backup plan, and all the stuff that went up in all the cities came back down, and we're back to the same old code that we had before, and no, there was no cake afterwards for that. But it's like, really, I wasted 4 months. But if I didn't have a backup plan, I'd be in big trouble. The next thing is setting up Exchange servers, setting up anything that has high visibility, anything that must stay up and running. That backup plan is so important. I just wanted to harp on that a little bit because I've had so much experience with that going well or not going well. All right, the next thing we want to do is make sure that we have protocols and accounts set up appropriately. Again, this is going back into hardening that system. We want to make sure we're not using protocols that can be sniffed, like SNMP, POP3, Telnet, etc. Making sure we disable WebDAV if we're not using it. Making sure we have all the backend accounts on NTFS, or if you're running Linux, you have to have those set up appropriately. Division of duty, etc. on those things. We also want to lock down our files and directories, eliminating any files that we don't need within jar files, disable directory listing, making sure that the non-web files like archives, backups, that you can't get to them, right? We want to get rid of those, and then disable certain file types that might be or allow resource mappings to be created. And we want to monitor that system. We want to detect anytime anyone is changing files, any processes that shouldn't be in locations, any files that shouldn't be touched by non-web app or web server processes. We want to monitor that also. And then what we want to do is make sure we have only the appropriate ports open, that we have correctly configured machine conf, server certificates, and code security. This is going to be important. We'll see this more in the next module. Over here, we're going to make sure that if we have a standalone web server, that we have ACLs to guard that. Those are access control lists. That the SAM is locked down, that we have appropriate permissions. So there's a lot we can do on the web server itself to make sure it's less vulnerable to attack. And then we're going to make sure the web server is on a dedicated machine. It's not on a domain controller. You might think you don't have to say that, but I've found web servers that are installed and running on like a SQL server or other type of application servers. If a database server like SQL Server is used, put it somewhere else. Separate all the roles for your web services. Limit the functionality. Make sure that you have hardened that web server before you put it in production. So very important. Just a few things here that you want to do. If you want to defend against response splitting, again, like I was talking about a little bit earlier, that this type of attack is involved in so many different types of exploits. The first thing you want to do is on the server admin, you want to make sure everything's updated and patched, and you run a vulnerability scanner. For the dev end, you want to restrict the application access to unique IPs. By the way, this is important overall in operations, and especially back-end operations. What you do is you allow only an internal IP to access certain components of your organization, so that if somebody comes from an external IP, they won't have access to it. Disallow that CRLF complying with RFC 2616, and then proxy, right? Avoid sharing those TCP connections among different clients. Use different TCP connections with virtual hosts. So there's a lot we can do to avoid that. And then for DNS hijacking, lock your DNS for your web app. Down here, include DNS hijacking in your incident response. And I will say for your incident response, include this entire list of attacks in your incident response and drill on it for your forensics team and your incident responders. Avoid downloading audio and video codecs from untrusted websites. I think that's kind of a priori also. But there are other tools that you can use. This one's called OpenText Fortify Web Inspect. Web Inspect makes a lot of good testing stuff. Acunetics, like I said before, makes a lot of good testing stuff. Saint and Sophos. So there are tools that you can use to make sure that your web services are as secure as possible. And then we have tools like Core Impact, which evaluates the entire security posture of your web server against modern cybercrime. And then, of course, we have Cobalt Strike and a few others out there that can be very helpful for defending your web server against attack. Okay, so we've come to the end of the web server hacking module. And in this module, we talked about vulnerabilities of web servers, techniques that you can use to hack web servers. We looked at some of the low-level functionality that we see that can be vulnerable in web servers. We looked at some of the tools that you can use to attack and defend web servers. We looked at Nmap commands. We looked at AI prompts that we can use to automate web server attacks. So we have a lot to try out when we get into the lab. So let's do the lab first. And then when we come back, we're going to go to our next module where we're going to talk about what runs on a web server, which is a web app. So that's the end of this module.